Hi everyone, how are you? I'm your Kusum ma'am. So let's start with today's topic. So today I'm going to explain about chemical effect of electric current. So this is of chapter 8, 8th standard chapter. So let's start out with the chemical effect of electric current. So here you all are already familiar with what are conductors and insulators. So I skipped that topic. What are conductors and insulators? So conductors are the substances through which current can pass easily, which has got free electrons, which allows the current to pass easily are called conductor, and the substance through which current cannot pass are called insulator. So here let's start out with the important topic of this chapter. How everyone? So now your exams are approaching. I feel like everyone are busy in your studies. So whenever you are starting your work, so once you go through with the concepts, if you revise the chapters, it will be easy for you to remember for your exams. So I advise everyone, so constant learning is not sufficient. Along with that, revision is also very important. So this chapter is very simple, and that I prepared in a short way so that you can complete the chapter in a single shot. What are electrolytes? So this is the new topic for you. A compound that conduct electricity in its aqueous. So what is the meaning of aqueous? That is molten. When it is dissolved in water, we call it as aqueous. Okay, when it is dissolved in water, we call it as aqueous state. So here, electrolyte are the compound that conduct electricity in their aqueous or molten state. Now, electrolytes are of two types. They can be strong electrolyte or weak electrolyte. So what are strong electrolyte? Strong electrolytes are those electrolytes that get ionized completely in its aqueous solution. So whenever we are going to use aqueous word in this chapter, be clear that it is dissolved in water. Now what is the meaning of ionize? Ionize means when it will form ions. So here, like if we dissolve salt in water, salt will split as Na plus and Cl minus. So when a compound dissolves as ion, we call it as ionizing. And when they are completely ionizing, they are strong electrolytes. So while you are talking about electrolyte, you might have considered, like the ma'am said, this is a chapter of electricity and its chemical effect, and what are these different things we are getting. So electricity, how we can pass out electricity in chemicals, that is chemical effect of electric current we are talking here. Now what are strong electrolytes? Which ionizes completely. So here first we need to frame electrolytes so that by introducing electrodes, that is positive and negative terminal in them, we generate electricity and will see the chemical effects. So for that purpose we need to learn about electrolytes. Now after strong electrolytes, few examples are NaCl, H2SO4, CuSO4. NaCl is sodium chloride, this is sulfuric acid and copper sulfate. Now what are weak electrolytes? Electrolytes that partially ionize. Partially means they does not ionize completely. Thus they are weak conductor. So as they do not ionize completely, they are weak conductor. They are called weak electrolyte. Example is acetic acid, CH3COOH. It is acetic acid, NH4OH, ammonium hydroxide. So these are the examples which partially ionize, means incomplete ionization. Now few examples are there of strong electrolyte and weak electrolytes. They can be asked in exam. So here seawater, nitric acid, which is HNO3, copper sulfate, NaCl, sulfuric acid, H2SO4. They are strong electrolytes. Tap water, oxalic acid. Oxalic acid is present in tomato. So sour substances are containing acids. Tomato contains oxalic acid, carbonic acid, ammonium hydroxide, citric acid. All citrus foods like lemon, orange, they contain citric acid. The example of weak electrolyte. Now the next topic is dilution of sulfuric acid. So how we dilute? So before getting them into electrolyte, we need to dilute, as the concentrated sulfuric acid is very dangerous to handle. So how the dilution is done? This is very important question. Even this is important for 10th CBSE also. So here, whenever we dilute any acid, that is while diluting acid must be added to water with slow stirring. Suppose we are having water in the beaker and then we have acid. Acid is in small quantity compared to water. As we know that dilution, how much we need to dilute. So we'll take water and slowly we add this acid with constant stirring. So we take some rod and with constant stirring acid is added. So why this is done? Because it is highly hexothermic reaction. So what is hexothermic? When lot of heat is generated, it is called hexothermic. As it is an acid, so here this whole container will become very hot. And if suppose we are adding water, the hotness will be too much that the beaker will blast and there may be chances of getting accidents. So we are adding acid slowly to water, that too with stirring. Slowly we will add it and we'll mix it. Now here water with slow stirring, water should not be added to acid as it is highly hexothermic reaction. Liberated heat may make the acid to splash and cause burning. So here always acid is added slowly. Water should never be added. So this is important point for dilution. This we are preparing electrolyte. Now the next one, non-electrolyte. So what is the name? Non. Non means they are not the electrolyte. So as they are not the electrolyte, so they will not conduct electricity. Unless they form ions, they will not conduct electricity. So non-electrolyte are those does not conduct electricity as they does not produce ions. For example, if we take glucose, its formula is C6H12O6. So when we dissolve it in water, it will not form any ions. So it is a non-electrolyte. Now, conversion of chemical energy into electric energy. How the chemical energy is getting converted into electric energy. This is the main topic of the chapter. That is main purpose. How we started chemical effect. Okay. Now, chemical energy can be converted into electric energy in electric cell. This type of cell was first used by an Italian scientist, Alessandro Volta. So Volta was the first scientist who used a simple cell. So what he did, he took a beaker and in this beaker he added some electrolyte. So here electrolyte, for that he took sulfuric acid and then two electrodes. One is made up of zinc and other is of copper. So one he took zinc electrode, other he took copper electrode. And then he connected both the electrodes externally with wire and a bulb was placed in the circuit. So to his surprise, he found that the bulb started glowing. So what does this conclude? That this electrolyte chemical reaction is taking place. So few ions from the rod will come out to the electrolyte and again they will pass out to another electrode. That is, electrons are coming out of one electrode and they are passing in another electrode and they are making the circuit to complete and current to flow. So as the current started flowing, so the bulb will glow. So this is called chemical effect of electric current. So because of the chemicals, electric current is generated. By using chemicals, we generated electric current. So finally we concluded that chemicals can be converted into electricity by generating ions in them. So here this is the experiment. He took a beaker and filled with little amount of sulfuric acid and two electrodes made up of copper and zinc are dipped in it. Chemical reaction will take place as a result of which electricity is generated. If we connect both the electrodes with metallic wire and LED bulb is connected. So as I told, when the bulb is connected, the circuit is complete and we find that the bulb glows. So here the bulb is glowing. This is called chemical effect of electric current. If suppose in 2 or 3 marks it is asked what is chemical effect of electric current, we need to write this activity. Now the next one, chemical effect of electric current. One more, like just opposite to previous activity, if the current is passed through liquid, it can produce chemical effect. So this phenomenon was given by Michael Faraday. So he was another scientist. He also explained that when electric current is passed through chemical. Okay, so here current is passed, just opposite. In the previous case, chemicals cause the current to generate. Here we are passing current through chemicals. So this was given by Michael Faraday. He observed that when current is passed through ionic solution, it causes chemical effect of electric current. He called it electrolysis. So the name given by this, when in ionic liquid, if current is passed, it causes chemical effect and that effect is called electrolysis. So whenever we use this word lysis, you need to remember that the thing is getting broken. When something split, we call it as lysis. Electrolysis, because of electricity, something is breaking. That is electrolysis. When current is passed through water, for example, water will split into hydrogen and oxygen. So water is breaking down by passing electricity. So we call electrolysis of water. Whatever is breaking, we call that electrolysis of that substance. This was given by Michael Faraday. Again, it can be 1 mark question. Electrolysis was introduced by whom? So it was given by Faraday. This is because it causes chemical change in electrolyte. So now we need to remember one note here. If current is passed through pure metallic conductor instead of electrolyte, so here we are passing current through metallic conductor. Conductor means wire instead of electrolyte. Electrolyte is liquid. Instead of electrolyte, we are passing current through metallic conductor. Chemical effect will not take place. Only wire will get heated. So now we are taken a wire and we are passing current. So here chemical effect is not taking place because no electrolyte is there. Only the wire will get heat up. So this you can have observed that when we charge our mobile, the wire get heated. That is, as current is passed, the substance is getting heated. Now one more activity, that is electrolysis of water. How we can do electrolysis of water? So as this is activity, we need to write in the experiment form. Aim to demonstrate the electrolysis of water. So we are getting electrolysis of water. What are the materials required here? A battery of 9 volt, that is 1.5 volt. Small batteries we have taken 6. 15 multiplied by 6 is 90. So we generate 9 volt. 15 volt batteries are taken, which are 6 in number. 2 graphite pencils. So as we don't have any electrolytes, so normal pencil is taken. A beaker, tap water, and connecting wire and tape. So these are the materials. Now let's start out with the procedure. Sharpen both the pencils and fill the beaker with tap water and complete the circuit as shown in the figure. So in the previous case, I showed you figure. So where the beaker is taken and two electrodes are kept. So here we are using pencil. So we are sharpening the both ends so that we can find the graphite end. As graphite is good conductor, so we are keeping the pencil leads in both the corners. Now here care should be taken so that there must be good contact of wire with graphite, and now cover them with tape. So we are covering whole the thing. Use cardboard to hold pencil at vertical position. So this pencil will fall down. So we keep some cardboard to give support so that the pencil will not fall. Now hold the pencils in vertical position. Expose the tip of the pencil to water. So here we are keeping the tip to water. This acts like electrodes. Now the pencils are acting like electrodes. After 2 to 3 minutes, observe the electrodes. So when we see electrodes, that is 2 rods, after 2 to 3 minutes, we find that there is bubble formation. So what is our observation? Bubbles will start forming near the electrodes. Scientist Nicholson showed that these bubbles are nothing but oxygen and hydrogen. So when we see this experiment, we find that some bubbles are generated near the electrodes. So these bubbles are hydrogen and oxygen. So this was given by the another scientist, Nicholson. So now till now we came across 3 different scientists' name. Now hydrogen is formed as hydrogen is positive in charge. So here hydrogen is formed at cathode, that is negative terminal. We have taken 2 electrodes. Negative one is called cathode, positive one is called anode. Hydrogen is liberated at cathode and oxygen at anode. Moreover, hydrogen liberated is twice the amount of oxygen. So here when we see, as water formula is H2O, so hydrogen will be twice to that of oxygen. 2 amount of hydrogen will liberate and 1 amount of oxygen. This is electrolysis of water. With this experiment, Nicholson concluded that electric current causes chemical effect. So here in the previous session, we read about chemical effect of electric current, and here the electric current is causing chemical effect. That is, because of passing of current, we are able to split water. Now what are the factors which cause chemical reaction? Okay, chemical reaction is taking place and few factors are there which are affecting it. The first one, for the chemical reaction, nature of electrodes are important. Which electrodes we are choosing? Nature of concentration of the solution. What is the concentration of the solution? That is also one of the important factor. And some other effects of electric current. Metal may get deposited at electrode. So when we pass current, as electrolyte is having certain metal that may get deposited at the electrode, And the second observation which we can see, that is gaseous bubbles may get formed near the electrodes. There may be formation of gases, there may be formation of bubbles. Change in the color may occur. That is, we have taken electrolyte. So what is the real process like? When we take electrolyte, see here how the electrolysis process is taking place. We need to take one beaker. 2 electrodes are taken. One is anode and other is cathode. Okay, this is, let it be anode and cathode. Cathode is negative terminal, anode is positive terminal. And we are taking some electrolyte. For example, suppose we are purifying copper. So this anode, this is I'm explaining electrolysis process. When we go for electrolysis, 2 electrodes which we choose, generally this process is used for purification or electroplating. So how that is done? Here we have taken anode, which is made up of impure metal. And cathode is always made up of pure metal. Suppose we want to deposit this anode on the cathode. So we will complete the circuit first. We have taken 2 electrodes. Electrolyte is taken. Whatever material we will take the rod, the same electrolyte must be taken. Now complete the circuit. So here, when current is passed, some amount of copper from anode will dissolve in copper sulfate. So whatever the amount of copper got dissolved, the same amount from copper sulfate solution will go and deposit on the rod. So after certain interval, what we find? So this anode is becoming thin, whereas the cathode is becoming thick. This anode, copper from anode is getting transferred to cathode. So this cathode will become thick and anode will become thin. And moreover, whatever impurities are present in the anode, they get deposited at the bottom. And we call this as anode mud. So with this word, you can remember the activity. Anode mud means anode is impure. So all the impurities are getting settled near the anode and cathode is becoming thicker. So with this, we get the electroplating. Suppose what is electroplating? Electroplating is a process of getting deposition of desired metal on any other metal. Generally, if you go for any artificial jewelry, so there on the jewelry, they get the gold polishing or silver polishing. That is by this method they go. And moreover, this is used for extraction of the metals which are top in the activity series, which are very reactive. They are extracted by electrolytic refining. So this process is very important, where the purification is done or electroplating is done. So most probably you understood the activity. So let's continue with the nature of the concentration of solution. So here, metal may get deposited at electrode. That is one of the effect we are getting. Or there is a formation of bubbles that we got in electrolysis of water, where hydrogen and oxygen got separated. And change in the color may occur. So as the ions are getting dissolved, electrolyte may change in color. Now what are the application of electrolysis? So first, I already explained you extraction of metal from the ore. So what is this ore? This is also a new topic for you. When we extract certain metal from the earth that is in impure form, okay, that contains all the variety. Suppose we are having some iron industry. In that case, we need to concentrate only on the iron. But the material which we get from the earth, it may contain copper also, it may contain sulfur also, it may contain magnesium also. All those things may be there. But as our industry is related to iron and steel, we need to concentrate only on iron. So out of that mineral which we got, we will separate out this iron content. So that part of the mineral which contains maximum amount of the desired metal which we need is called ore. So ore from which particular metal can be extracted profitably. So simple definition, from which particular metal can be extracted profitably is called ore. For extraction of metal from the ore, we use this electroplating method, that is electrolysis method. Certain metals are extracted from their ores by this process. Example, sodium and potassium. Next is electro-refining of metals. Here we are going for refining, means purification. As I told, impurities can be removed in the form of anode mud. The process of obtaining pure metal from impure one by the process of electrolysis is called electro-refining. There you need to explain about electrolysis process along with that electrodes and anode mud. copper, pure copper rod is made up of cathode and impure cathode rod is made up of anode. Already explained, impure is anode and pure is made up of cathode. And copper sulfate solution is taken as electrolyte, where you can explain this whole process. Now the next use which we are having is electroplating. So this also I told, like the process of depositing the desired metal on another material by passing electric current is known as electroplating. So we are doing plating with the help of electricity. So we call it as electroplating. And what is plated here? The desired metal. Whatever the metal we want to plate on another. This process is used. Electroplating, it is used to plate out the some of the vessels also, or to make some articles attractive, or the statues. Electroplating is done. On the jewelry, electroplating is done. So these are the few effects of electric current, or how the current and chemical reaction is interrelated, how the chemical reaction is helping the current to pass, or how the current is making the chemical reaction to happen. So this is the main gist of this chapter. So both are interconvertible. Current can generate chemical effect, and even the chemical effect can generate electricity. So this is the simple way we did this chapter within 20 minutes. Most probably all of you understood it once you go through with the video nicely twice or thrice. For more videos and more information, please like and subscribe my channel.